A particle of mass 0.4 kilogram is moving with a constant speed of 10 meter per second towards north, is subjected to a constant force of 8 Newton towards south for 30 seconds. Suppose the force is applied at t equals to 0 and the particle is at that time is at x is equals to 0. Predict the position of particle at t equals to minus 5 seconds, t equals to 25 seconds and t equals to 100 seconds. So let us try to understand the question. So there is a particle of mass 0.4 kg. So this is moving with a constant speed of 10 meters per second towards north. So let us consider this is north. Now it is subjected to a constant force of 8 newtons directed towards south. So in this direction the force is applied. That force is applied for 30 seconds. So this force is applied for 30 seconds. Suppose the force is applied at t equals to 0. So at t equals to 0, the force is getting started to apply, and that means it is acting from t equals to 0 to t equals to 30 seconds. Okay, and particle at that time is x equals to 0. So when t equals to 0, x is also equals to 0, and from x is equals to 0, the force is applied. Okay, so the force is applied at t equals to 0 and the particle was also at x is equals to 0 when the force was started to apply. Now we have to predict the position of particle at t equals to minus 5 seconds, 25 seconds and 100 seconds. Now please try to understand this. We are applying force only from t equals to 0 to t equals to 30 seconds. So we know acceleration is equals to force by mass. That is, force is how much? 8 Newton by mass is 0.4 kilogram. That is nothing but 20 meter per second square. So this is the acceleration. And we are applying in opposite direction. So let me take, it is minus 8 Newton. So it is minus 20 meter per second square. So velocity is in this direction and force is in this direction. So I am taking it in the minus I am taking. Now this is the acceleration which is produced only when force is applied on the body. So force is applied on the body only when time is equals to 0 to 30 seconds. So during that period only there will be acceleration on the block. Remaining time t equals to before t equals to 0 and after t equals to 30 seconds there will not be any force. So there will not be any acceleration. So while we are using equations of motion, we have to use acceleration is equals to minus 20 meter per second only if the time is in between 0 to 30 seconds. So for remaining things we should not use this acceleration. Let us move to the first question, that is at t equals to minus 5 seconds. Okay, so we know x is equals to ut plus half at square. What is the initial velocity? It is given that it is 10 meter per second. It is moving towards north, and then what is the time? It is minus 5. Acceleration is 0 because I have already told it is only for 0 to 30 seconds. So here time is given as minus 5 seconds, so we should not use that acceleration. So now we can substitute these things in equation. 10 into minus 5 plus half, acceleration is 0, t square is minus 5 square. This is minus 50 meter. So this is the position of particle at t equals to minus 5 seconds. Now let us move to the second question, t equals to 25 seconds. Here we know u is equals to 10 meter per second. Acceleration is equals to minus 20 meter per second square. Why? Because 25 seconds. During 25 seconds there will be acceleration, because acceleration was from 0 to 30 seconds. So definitely at 25 seconds there will be some acceleration, and that is equals to minus 20 meter per second square. We have already found. Now we can substitute in the formula. X is equals to ut plus half minus 20 t square, 25 square. this on solving we are getting 250 plus this is minus 10 into 625. So that is minus 6250 plus 250. That is minus 6000 meter or minus 6 kilometer. So this is the position of particle when t equals to 25 seconds. Now let us find what is the position of particle at t equals to 100 seconds. So for first 30 seconds, from the 0 to 30 seconds, it is moving with acceleration minus 20 meter per second square, and its initial velocity is u equals to plus 10 meter per second. Now after this, from 30 to 100 seconds, it is not having any acceleration. So here acceleration is 0 for this 30 to 100 second journey, and so we will use equations of motion separately for this case and for this case. Okay, so let us find what is the position at t equals to 30 seconds. That is s is equals to ut plus 10 into time is 30 seconds plus half acceleration is minus 20, t square is 30 square. So this on solving we are getting minus 8700 meters. So this is the position of particle at t equals to 30 seconds. Now because there is some acceleration present, its velocity will be changed. Okay, initially it is starting with velocity 10 meter per second, but when it is reaching 30 seconds, its velocity will be changed. What is the velocity at t equals to 30 seconds? V equals to u plus at. U plus at. U is 10 meter per second plus a is minus 20, time is 30. So it is minus 590 meter per second. So when it is reaching 30 seconds, when it is at 30 seconds, it is having some velocity that is minus 590 meter per second, and it is not same as 10 meter per second. Why? Because there was some acceleration. If acceleration is present, then we know velocity should be changing. If velocity is changing, and we are finding what is the velocity at t equals to 30 seconds. Now why are we finding velocity at t equals to 30 seconds? Because this is the initial velocity for next time interval, next part of journey, that is 30 to 100 seconds. This will be the initial velocity. So only we are finding this one. So now let us see for remaining part what is the distance it is traveling. So that is s is equals to ut plus half at square. Again, what is u? Initial velocity is minus 590 into time is, what is the time interval? That is 100 minus 30 seconds, that is 70 plus half acceleration is 0, t square is 70 square. So this is minus 590 into 70, that is minus 41300 meter. Now this is the distance that is traveled in next 70 seconds. Okay, so for first 0 to 30 seconds, it is traveling some distance, that is minus 8700 meter, and for next 70 seconds, it is traveling a distance minus 41300 meter. So when time is equals to 100 seconds, its position is this plus this. Okay, that is 8700 and 41300, that is equals to minus 50,000 meter. Okay, let us see why we are adding these two things. Suppose the body is starting here, okay, at t equals to 0. It is now we are applying a retardation. Retardation is 20 meter per second square. So it may be starting in this direction, but because of that, we have seen it is at 30 seconds, it is at my 8700 meter, and it is minus 8700 meter. That means it has moved in this direction because of that retardation. In this direction it is starting to move. So at t equals to 0 it was here, and its net displacement in this direction, and at t equals to 30 seconds this is the position, that is minus 8700 meter. Okay, and further we are applying equation of motion for, so this is 30 seconds, from 30 seconds to 100 seconds, and from 30 seconds to 100 seconds it is moving a distance of 41300 meter, that is this distance will be 41300 meter. Okay, but what is asked in the question, what is its position at 100 seconds? So this is 100 second, so its position at 100 second is, we have to add this whole thing, that is minus 50,000 meter.